Внимание присутствующих, я хотел бы предложить информацию
I'd like to talk about the work that we do in instrumental ceramics based on dense modifications of boron nitrides. Our work has a practical application, so therefore I will mostly dwell on this practical aspect. So this is the structure of the materials that we obtain. The technology that we offer allows to regulate the structure and the state of the material, and by doing so obtain the material with custom tailored properties. We can have a two-phase system or monophase system. The structure of a material is very dispersed, and this allows to use the tool of such ceramics on final operations and operation on the groups where a significant effort for cutting is necessary. So this is obtained by applying special technology which foresees the availability of various technological methods that helps to form such a structure or material. The material that is listed here and its properties here, take a look at these characteristics. You see that two-phase system has fracture toughness and hardness, while single monophase system has lower characteristics. But on the other hand, if we take thermal stability and thermal conductivity of monophase system, it can work at higher temperatures. So this defines the potential use for particular modifications. For instance, for a non-stop shearing, this modification is good, but porous surfaces are best sheared with this kind of material. What are the advantages of the tools that were based on these materials? Boron nitride based materials is compared to iron, because iron is still the main element for construction, bearings, machine building, parts, and not only that. So this is the most widely spread group of metals. The advantages of these materials, among the advantages, is that the cutting edge is redundant and it lasts much longer. Reliability of the tools by high fracture toughness. The applications, mechanical processing during turning and milling of hard to machine materials, the high manganese steels, gut-filled steel type. As you know, they're hard to treat. Usually the phase mechanic treatment is used. But with this kind of treatment, there are fractures in the porous layers, and where the life cycle of such material is much shorter. And chromium steels and hardened high carbon steels. Such tools are positive in the way that It allows for radically changing the chain of production of whole number of materials, because you can treat and process the already pre-made parts and materials, and so it allows us to have a much more flexible technology. This here shows the typical tools using such materials: lathe tools, milling cutter, cutting the steel. What are the materials that are effectively used? The special steel with hardness up to 5862, and these kind of materials can also withstand high impact pressure. So any kind of surface can be treated with these tools. A gat-filled steel can be treated with these tools. Chilled cast iron and high chromium seals, such as ICH28, which is very hard to treat with the regular tools. I think we should point out the indicators for this technology. Comparing the two technologies. What are the disadvantages of traditional tools? Low productivity, high energy consumption, the structural changes in surface layers, because the plasma leads to these changes, and environmental degradation, dust and exhaust. Using the tools from the materials that we suggest allows to increase the productivity sixfold, allows to reduce the energy consumption 3-5-fold, improve the quality of the treated surface for 2 or 3-fold, and of course the life cycle products that are treated with these tools is much longer, because there is no damage to porous surface layer. And of course the environmentally clean technology. Other advantages of the tool: the high speed of cutting, huge capacity, high precision of the treatment, heat sink of the cutting zone, and the high quality of the treated surface. This work is described in 3 documents. There are 2 patents, and the initial work, which dates back to 1990. And the last thing, the economic feasibility. It allows to increase efficiency 3 to 4 times, and the quality of treated surface is increased 2 or 3-fold. We are interested in cooperation, closed cycle, of wide spectrum of instruments, and entering the market with the ready-made tools used from these materials. Thank you. Questions? Could you tell us the scope, the range of work for these tools, the work that can be done with these tools compared to diamond-based tools? Please, microphone. Now, diamond-based tools are not comparable, because they are used with different kind of metals, with colored metals. We can only compare with hardened steel alloys or similar materials, composite materials, ceramics.
Но, в принципе, мы вот провели широкое испытание в металлургической промышленности. Вот,
We did some extensive testing in metallurgy and the factories where there are grinders, and the elements in those grinders are made from gat-full steel and are very hard to treat. And other types of materials that are named: the hardened steel, the chilled cast iron, the chromium-based steel, manganese-based steel. So this type of materials.
let me give